So guys, I'm back with yet another lead code problem video. So today we are going to do another recursive backtracking problem. So this is the 46th problem in lead code permutations. So the objective here is to find the permutations of a given array, or we can use it on a string also. So the question is as such, you have to take for example, let's take the first test case, 1, 2 and 3. They're there. So we have to find all the possible permutations. So what are all the possible permutations? Let's imagine we're starting with 1. The possible permutations can be 1, 2 and 3 itself. That's the solution itself. And then we have 1 comma 3 and 2. We can have that. And then we can have with ones everything is done, so we can start with the 2, 1 and 3. And then we can have 2, 3 and 1. We can have these 3. And then what else? Starting with 3 we can have 3, 1, 2. And then we can have 3, 2, 1. Yeah, so right now how many solutions you got? 1, 2, 3, 4, 5, 6. So the solution is of n factorial ways we can get the solution in. So if the input is 3, then we have the number of the array size is 3, then we have 3 factorial, which is 6 solutions we can have here. So as you can see here there's 2 solutions, so there are 2 factorial solutions for this, for 2 elements in the array. So for 1 we have only 1. So this is a kind of recursive problem. We need to do the recursive approach. This question is kind of complicated, but this can become a template for the upcoming questions which we do in the future. So as we do more recursive problems, we'll get a clear idea on how to use the recursive tree and how to approach a problem without getting scared. So I was thinking of an approach in such a way that so we use backtracking. So let's understand the recursive tree first. So imagine we have 1, 2 and 3. Imagine these 3 are there. So how can we create permutations out of these 3 characters? So I'll show for one branch of the recursive tree, then you can understand the remaining branches are similar to this branch. So we can start from so first we'll try writing the function, and then we'll get back to the explanation once. So initially we would need a list of we need a list, and then this is going to be the inner list, array list. So we need one more list. This is going to be a list of lists. This is going to be the answer list, which we're going to return in the main function. And then we would need so yeah, so we need these, and then we'll return the answer. So let's write the function first. Let's define how a function should look. So it should be it's a helper function, and then we need the array itself, the nums array, and then we'll need the list. We would need this, and then we would need this answer array list, and then we would need a boolean array which contains a frequency. Yeah, so this is how our the function should look, the helper function. Let's define the helper function here, and then this is going to not return anything. It's just adding elements to the answer list. So, and right now we will create our base case. So our base case is such that the recursion should end if the nums dot length is equal to the inner the inner list whichever is present, which we are going to add to our answer list. So if they say, then we would just add it to our answer list, answer dot add last time I did this mistake, so I'll rectify it this time. So new array list, so it's going to be, yes, yeah, no, it's going to be inner, and then we'll return back to the main this thing. So till now, so far it's good. So now we have to write our main function. Okay, so I'll tell you why we need the boolean array. Why do we need it? So right now, imagine we have 1, 2 and 3. So if you want to, right now we can start, as I told you, as we do it. So we can start with the first element, and then first we would have 1 initially. With 1, what all can we have? With 1 we can add a 2 and 3, or we can add a 3 and then a 2. So these are two ways. So if we start with a 2, we can add a 1 and then we can add a 3, or with 2 we can add a 1 and then we can add a 3. So similarly with 3 also, that's what we can do. So I'll explain one branch right now. So imagine this is the function, this is the recursive function. Okay, I'll explain the function here right now. Nums is the array itself which is given, and then this is the inner list. See, this one you see in the box, it's the inner list, and answer is the answer array list, obviously, which you're going to return in the ending, which are to which we are adding all the inner lists. So, and now this is the boolean array. So boolean array is going to keep a charge whether we have added the element or no. So this is going to have ones and zeros. If it's a 1, it means we have added the element to the main list. If it's a 0, we haven't added it yet, and we can add it. So we have a chance of adding it to the main list. So right now with 1, we can add a 2 or a 3. So if we add a 2, we have to, so I've added 1 here. So I've made this a 0th element. So this into 1. This boolean array has turned into 1. And right now I can add a 2 or I can add a 3. So what if I add a 2? If I add a 2, the answer list remain as it is, and then we add a 1 here because we have taken it. So number 2 we have taken it. So we have added a 1 here. So and then 2. So what all options we have after 2? We can add only one element, and that is 3. So now I have added a 3 here. So when I have added 3, I have removed it. So right now the base condition hits here. See the base condition. So the inner list and the length of the array becomes same. So we add this to the, so you can see here, add array list to inner value. So we added it to the inner list. The inner list has been added to the answer, and then we have returned the value. So when we return here, so while returning, we have to remove this. So we have to remove this 0 and then this 3 and come back here. We have to backtrack, like basically we have to backtrack, and after backtracking 1, we can add a 3 here. So it has come till here. So we can add a 3 here. So while adding a 3, we do the similar thing. So after adding a 3, we have only 2. So this is an option, and we come back to the initial array, and then it again, instead of 1, we can start with a 2. We can start with a 3. Similarly, all the 3 branches look the same of the recursion tree. So I'll code this up, and after coding it up, we'll again explain it. So we'll just see it once. So we need a for loop. This for loop is there so that we can keep a track, we can iterate to the whole array and add elements respectively, and we can update the boolean array also. So we have to iterate on nums dot length. Yeah, so you have this array right now. So we have to iterate through this. So we have to check whether the given element is empty or no. The even given element in the array is empty or no. First, if frequency is false only, we do some action on it. Otherwise, we don't do anything on it. So if it's false, now we will make it true because we are going to add an element to it. And after adding an element to it, we would right now after adding and after changing it to true, we would add the element to the array. So the nums, the inner dot add, which is going to be frequency of, we are going to add the element. So how do we add it? So what do we add? We add nums I. We would add this to our array. We would add this to our array, and we would do a recursive call here, helper function. So we would nums is normal inner after adding this thing, and then we would have a answer array, and then we would have a frequency. Yeah, the frequency is updated, you can see. And now after doing all this, again we would backtrack. So till now this was the recursive tree to go down, now to come back to return to the values. So now we would remove the the element which we added in the ending, inner dot remove inner dot size -1, and then we would make the frequency again to normal. So it's like we removed the element and now we would uncheck it, so it's equal to false again. Yeah, we would uncheck it and it's false again. Yeah, I think that's it, and the helper function is finished. So we have to create a boolean array right now. Frequency new boolean. This is going to be of the same size as the input array. Nums dot length. Let's check the array again. Nums dot add. So let's run the code and check once. Sorry, I instead of passing the values have, this is not the way. Wait a minute. Okay, so the helper function takes the nums, and then it takes the inner array and then answer array, and then the frequency would be taken. Now we will run this. Yeah, so it has been accepted. Let's submit and check once. Yeah, so we got the answer. So this might seem complicated initially. So this recursion tree you see right now, so you have to, so each time the data structure is, we have an array in this, and then we, in that array, boolean array would be updating the value whether it's taken or not taken. So initially we would take 1, and then after taking 1, what all things we can do, and after taking 2 initially we can take 1, or we can take 3, or we that. So these combinations, so I suggest you people to draw the recursion tree and test it out once for this idea, then it would be very easy. So I hope you understood the solution. Thank you very much. Bye.